In this video, I would like to explain why the definition of e, the base of natural logarithm, is e is 1 plus 1 over n to n, then limit n is go to infinity. It seems there's no connection of this definition and e, but if you agree with two assumptions, I can show you that. First assumption is any number x to 0 is equal to 1. X is non-zero case. That means e to 0 is also 1. And the second assumption is the e's property, the derivative of ex is equal to ex. Let me show you my coordinate system and let's approximate e. So I want to know the e value, that means e to 1, which is e. But what is e? What I know is this e to 0 is 1, so let's start with this point. That e to 0 is 1, and I would like to approximate. But this derivative is also 1. That is the second assumption. This derivative of e to x at 0 is e to x to 0, and that is e to 0 and 1. That is from these assumptions. It looks like this. So here, this is 1, this is also 1, because derivative is 1, and that means e's first approximation is 2. But of course, this is too rough approximation. So next step, I subdivide 0 to 1 to half, and then here is 1 half, here is 1 over 2. Now start with the same, e to 0 is 1, and then I go half here, and here derivative is 1, and like this, here is 1 over 2, and 1 times 1 over 2 is 1 over 2. So this height is 1 plus 1 over 2. Please note, at this point, derivative dy dx is 1 plus 1 over 2 because it's equal to y. This is a y according to the second assumption. So therefore, next step, next this triangle, here is dx, and here is derivative times dx, and then here derivative is actually same to y, therefore 1 plus 1 over 2, and dx is 1 over 2. Okay, this is the point. Let's do it again. And the next step here, here, this point, derivative is 1 plus 1 over 2, and then go 1 half. And then derivative times dx is this height, that means 1 plus 1 over 2 times here, dx 1 over 2. So this height here is, start with here 1 plus 1 over 2, 1 plus 1 over 2, and then go this height. That means plus 1 over 2 times 1 over 2. I factored out this 1 plus 1 over 2, and then here is 1. Oh, make a dark color. 1 and 1 over 2 is factored out. So here is 1 plus 1 over 2. That means 1 plus 1 over 2 to 2 squared. Yeah. Now you see some kind of pattern here. I would like to go further. Now, this time I would like to subdivide here is to n. So that means one section is 1 over n. First step is the same. It starts with e to 0 to 1, and then here 1 over n, dx is 1 over n, and then here derivative is 1 times 1 over n is 1 over n. That means here height is 1 plus 1 over n. Start with 1 and then go this height. So this is 1 plus 1 over n. Next step is here, and then this section is also 1 over n, and then what is this height? This point is this value, and derivative is the same. Therefore, derivative times dx, which is 1 over n, and then this height I know now. That means this height is 1 plus 1 over n, that is the starting point of this point, and then you go further this height, and then plus 1 over n times 1 over n, and then I factored out again 1 plus 1 over n, 1 plus 1 over n. Here is factored out. That means 1 plus 1 over n to square. Now the third part is the same discussion, and then starting with this point and how much this is. Derivative is the same plus this value. So the derivative 1 plus 1 over n to squared times dx, which is 1 over n, 1 over n. And then start here, which is this value. Therefore, this height is 1 plus 1 over n to square plus 1 plus 1 over n square times 1 over n, which is again factored out 1 plus 1 over n square times 1 plus 1 over n, which means 1 plus 1 over n third. And then you go further to n. Go and go and go. And if you reach to n, which is e. So here is n subdivision, then this point. This point is 1 plus 1 over n to n. And then I would like to subdivide this n infinity. So the limit n to infinity, this is e. You see the definition of e is derived from these two assumptions. Now I would like to show some numerical result. So let's plot this. First I set n, the number of subdivision is 1, the simplest one, and then x is 0 to n. And then y, this is 1 plus 1 over n power to this x. Now this is approximation e to 0 and e to 1. Let's plot them. I have prepared the plotting function for this 1 over n times x and y and zn. Oops, something wrong. Oh, here. So this is plotting. Here is starting with 1 and derivative is 1 go to 2. Let's go to 2. So this is the first approximation. And if I go n to 4, so 4 subdivision, and x is like this, and the y is like this. Let's plot this. So now you see the first is derivative is going up, and the upper curve is actually e to x. And this curve is much closer than the first one. And I have the same function here, and I can just give the number of subdivision. So which is this one, and 10 subdivision is like this, and 20 subdivision will like this. I can make a small animation 1 to 30 and plot with this eye, and just pause some 0.3 seconds, and let's see. So go to the closer and closer. This approximation goes to closer to ex. I hope you enjoyed this video.